Good morning, participants. We will be starting off the session in another 4 to 5 minutes. Let more participants also join and then we'll start.
Amrita, you can start now.
Unupam Dey sir, I hope I am audible.
Yes, you are audible.
Yes, ma'am, you're right.
Okay. Well, starting the day as usual with a quote. We need technology in every classroom and in every student and teacher's hand because it is the pen and paper of our time. It is the lens through which we experience much of our world by David Warlick. Well, a very good morning and a warm welcome to all the participants who have joined with us on the third day of the online faculty development program on innovation in recent trends and research applications on computing and informatics to SET 2023. The speaker whom we have with us today is Professor Paramartha Datta, who will be delivering his lecture on effective computing. Professor Datta is currently working as professor in the Department of Computer and System Sciences in Vishwabharati University, Shantiniketan, since November 2007. He has been the co-author of 8 authored books, apart from 21 edited books, and more than 280 research publications in peer-reviewed journals and conference proceedings. In addition, Sir has also been the inventor of 17 published patents. Sir has also been the recipient of Excellence in Science and Technology Award 2018 conferred by the Indian Science Congress Association, Government of India, and INSA Teacher Award 2019 conferred by the Indian National Science Academy, Government of India. Dr. Datta has also been involved in several research projects, and one of those is DST-funded project entitled Development of an Intelligent Recognizer of Component Analysis of Manhole Gas Mixture in collaboration with Bengal Engineering and Science University, Shibpur. His active works include performance evaluation of evolutionary class of algorithms, Binary object extraction using bidirectional, self-organizing neural network architecture with fuzzy context, sensitive thresholding, and many more. Sir has also been the reviewer of various journals, including IEEE Transactions on System, Man, and Cybernetics, Pattern Recognition, Signal Processing, IEEE Communication Letters, Journal of Phytopathology. Sir, we are extremely happy to have you here with us today. Now I would request you to please continue with the session.
Thank you. Am I audible?
Yes, sir, you are audible.
Okay. May I start, please?
Yes, sir, sure, sir.
So thank you for giving me the opportunity to share some of my uh, points. So let me put my video off because it is otherwise very bandwidth hungry. So picking the thread from what I was talking about. So thank you very much, organizers, for giving me this opportunity. What I am going to talk today is effective computing. Unfortunately, it is misspelled as effective computing. No, effective computing deals with an interface area uh, which is basically interface in the sense that it has got cognitive science, where some medical science or application of medical sciences is there, and well, then there is the question of computational scientists uh, who play active role in pattern recognition. So basically, effective computing deals with different type of emotional or emotional aspects of human beings reflected because of muscular, I should not say distortion, but muscular actions. So there may be different type of expressions or different type of uh, you know different type of uh, different type of reflections that may crop up in the form of gesture, expression, etc. So what happens is that if I am angry, it is reflected in my face. If I am joyful, it is reflected in my face. So the problem of effective computing deals with such type of situations where to get an estimate or idea about what exactly uh, the emotional character of a human being is persisting at a particular point of time from his or her face image. Okay, so that means your input is essentially an expression, facial expression, uh, available in terms of typical images or sort of video images, and we shall try to identify which type of emotion the person under consideration is uh, in. Okay, so that is what is a part of effective computing. So let me share my slides. Am I audible?
Yes, sir, you are audible.
Okay. So let me share my slides. Is it visible?
Yes,
Yes,
sir,
sir, it
it
is
is
visible.
visible.
So the topic that I am about to talk uh, on is essentially recognition of change of human emotion from face image sequence. So before I get into the topic in details, let me clarify one or two points. First of all, it's a question of change on human emotion. So what happens is that my input is a video, sequence of video images or a sequence of images, so to say, where there is a transition. Say, for example, right now I am in neutral psychological position, but because of some factor or whatever it may be or some phenomenon, I get irritated and I become angry. So definitely there will be a transition reflected in my face. from neutral position to anger. Okay, so naturally this transition will be available in terms of certain sequence of video images or sequence of images, facial expressions, and the
মানে
challenge here is to.
প্রজেক্ট করছি আপনার তোমার যেটা প্রেজেন্টেশন হচ্ছে
Is it all right? Am I audible? Am I audible?
এটাই কি এফেক্টিভ কম্পিউটিং?
Effective computing, not E. It is A. Effective computing. No, it is misspelled there. Okay. So effective computing, as I have specified, it deals with recognition of mental state of a person or psychological state of a person from some expressions, may it be face image, may it be gesture or otherwise. Okay, so effective computing otherwise is a big domain, deals with cognitive science, some applications of medical science, pattern recognition, challenges, etc. So all these things put together. Is it all right? No? Is it clear? Hello?
Yes, sir.
Okay. So,
Yes, sir.
may I continue, please?
Yes, sir, you can continue.
Okay.
Please continue.
Now, for the present problem, let me repeat. For the present, what I am dealing with is essentially trying to get hold of or identify a change in human emotion, if there be any, as reflected in his or her face images over some time. So there will be images coming in sequence like that, and which images are reflecting the change in emotions. For example, from neutral to surprise or from neutral to anger, something like that. So these sequence of images are taken as input, and from this input, our objective or our challenge is to identify that, well, the background emotion, the person under consideration, of the person under consideration is, there is a transition or change in the emotion from say neutral to anger or something like that. Okay, so basically, given the sequence of inputs in the form of facial images reflecting the emotional or psychological status of a particular human being, that the emotional change is going to be, or is basically attempted to be identified or classified. That is what the problem is for the present. Okay. So honestly speaking, this is a research problem, and so what I am going to discuss today is basically a particular, the particular thesis work of one of my scholars who has recently awarded his PhD degree. So it is his, the content is his thesis. For obvious reason, I am not going to go into all the details of the thesis, because for two reasons. First of all, there will be, time constraint, number one, and number two, all the, mathematical and other technical details may not be of that much appreciable given this constrained time scenario. Okay, so considering that, we shall try to, my effort will be to put my talk content or material to a level which is possibly appreciable to all the audience. So let me proceed. So as I have already mentioned, this is a work of a thesis. So naturally, the structure will get that very much resemblance in the structure of a thesis. So the presentation is, a major part of the presentation is very much oriented in terms of a thesis-like structure. Okay, so as it happened, basically there were Apart from the introduction, literature review, and conclusion, etc., there are 4 contributory chapters. The entire thesis contains 4 contributory chapters, and with each and every chapter 3 to chapter 6 in between. So in these contributory chapters, I mean, we adapted different type of mechanisms or different type of methodologies. With each and every methodology, each and every procedure has got its strong points as well as weak points also, or demerits also. So naturally, in course of my talk today, I shall try to touch these individual components as per time permits, one by one, and we'll see how different type of methodologies work for this particular problem, how effectively they perform, etc. Okay. So that is what it is. Now, as has already been mentioned, it is basically the reiteration that what is the objective. Objective is the identification of spatio-temporal information. Temporal in the sense that since it deals with sequence of images, so naturally the question of this sequence is important. That means in which order, temporal order or time order, the images are appearing one after another. So that is important. Order is important. So that is why it is spatio-temporal information. In transition of human emotion using facial geometry-based approach. So basically, what we are dealing with in course of this thesis as well as in course of our discussion today is basically, geometry-related aspects. In fact, more so the geometry, coordinate geometry, or the understanding of coordinate geometry will be what we require for the present, other than very basics of image processing. So I reassure you that we are not going into the details of mathematical and other technical aspects. Rather, we put all the material, all the discussion within a level that is possibly appreciable or understandable to major part of the audience, if not all. Okay. So, facial expression analysis, in course of the objective, facial expression analysis will be there. Some innovative methods will be there. In fact, those 4 methods, which I have already pointed out, then change detection in human animation. That is what the purpose of the present talk is all about. Okay. Am I audible and visible?
Yes, sir. You are visible as well as audible, sir.
Okay, thank you. So, looking from the perspective of a system, so after all, we are dealing with a system. Essentially, it's a recognition system, and what does it recognize? Basically, human emotion recognition systems. Right? So now, point is, one of the classifications is, in fact, the most popular classification, the way different emotional states of a human being are identified. They are of either of these 6 categories: anger, disgust, then fear, then happiness, sadness, and surprise. Apart from the neutral, face image or neutral emotional situation that a human being may be in. So apart from neutral, which is always there, other than these are the 6 basic facial expressions we encounter as per the most popular, facial expression literature suggests. Okay, so this is to say that different literatures have identified different type of different combination of basic facial expressions, but these 6 basic facial expressions, these are considered as the most popular way of representation. So let us accept it, and in fact, all our discussion will be on the basis of this. Now, intelligent emotion recognition is the process of understanding human behavior, which comes under the purview of the present challenge, identifying of mental disorders, whatever it may be, and human-computer interaction. Now, honestly speaking, looking at the things, they may sound quite interesting, but in terms of research challenges, they are quite a prominent research challenges. Okay, in fact, let me share at this outset whatever we could do. There are so many demerits, drawbacks, and so many things yet to be done, yet to be covered. So, in fact, at the fag end of my talk, if time permits, I shall try to identify those. And in fact, uh, you are welcome. If you feel that it is of interest, you are welcome to contribute. Well, an ability to imitate the human sign language in non-verbal communication. This is important. Non-verbal communication shows the importance of facial expression recognition or machine-based facial expression recognition system. Now, this is the difficult part. So the point is, if I am angry, uh, now it's very difficult to quantify. So, for example, look at the figures represented left hand side. So take any arbitrary basic facial expression. Say fear. Okay. So we appreciate from the face image that it is fear, it is surprise, it is disgust, so on and so forth. But if someone raises a point, and that too pertinently, that how exactly say anger is different from disgust. I mean in quantitative sense. Okay, so it's very difficult to specify. So it's something which we can qualitatively feel, whose qualitative reflections are there in the form of expressions that we perceive, that we visualize. But if it comes to the question of explaining why it is fear, and or say why or how it is disgust, is very difficult to answer in quantitative sense. So that itself is a big challenge. Now, facial expressions of human alone have 55% contribution, certain statistics, contribution to capture the internal meaning of spoken messages, and in case of vocal and verbal cues, it is 30% and 7%. So this is as per the statistics revealed, and it is reported in one of the reportings. Okay, so as I have already mentioned, that we are dealing with 6 basic expressions. That means that framework where 6 basic facial expressions are considered, as they have been pointed out through figures on the left hand side. Okay, so this is what exactly our foundation, or on which we carry out all our analysis, study, etc. Okay. Now, coming to the system background, so before we go, before we become involved in the system study and subsequent analysis, let me try to make the background or clarify the background first. So, in respect of the system background, it's a traditional facial expression recognition system. This is abbreviated as FERS, and is a very popular abbreviation in the contemporary and relevant literature on affective computing. So FERS otherwise is very much a well-known abbreviation used by affective computing research community. Okay, so here it is. Now there are two distinct directions, or the two distinct initiatives that may crop up. One is related to feature extraction, and another is expression classification. And in feature expression, there are two approaches, primarily appearance based and geometry based. We have already mentioned that our primary focus will be geometry based. There are appearance based appearance-based reportings also, some of which are also very effective. And it is very difficult to say which out of these two approaches, appearance-based or geometric-based, which one is more effective and how. No, it is not so. Basically, it's not that these two approaches or these two methodologies are contradictory to one another. No, they are basically complementary to one another. Coming to expression classification, when it comes to the question of classification, the classifiers that may be very much suitable or applicable in different contexts in this particular type of problems, maybe MLP, which is abbreviation of multi-layer perceptron, support vector machine, or in short SVM, K-nearest neighbor or KNN, etc. So these are used for classification and learning task. Okay, so this is the basic framework or background which we must have to keep in. We have to keep in mind for further. As we proceed further. Am I audible and visible?
Sir, yes, sir. Yes, sir. Hello? Yes,
Okay.
sir, you are audible as well as visible, sir.
Okay. Okay. To continue that, appearance-based feature extraction, which exactly is not within our scope for the present, it uses different, just to get an understanding or clarify what exactly or how exactly it deals with. It uses different statistics of image pixels and produce the feature set by extracting histogram-oriented information, texture information, etc. from face images. So the primary orientation is different in appearance-based feature extraction, where how the feature is appearing, that is given more weightage or more importance rather than the geometry inherent in the scenario. On the contrary, in geometry-based feature extraction, it is the geometry, that means some geometric aspects must be there, which are explored and exploited. So geometry-based feature extraction mechanism uses geometric locations of facial points on face images and produce the feature set by extracting geometric shape information from face images. So the basic purpose is to explore and exploit underlying geometry that is available in the form of information in the facial images to identify the background, psychological state or emotional state of the particular human being. So that is what geometry-based feature extraction mechanism works. So our basic purpose or basic, treatment is geometry-based, as has already been mentioned, and we shall see how effectively they can be done. Now, coming to the specific motivation of the present work, there are two possibilities. One is static image-based approach or static image-based mechanism, where it uses only single image, either neutral expression or peak expression. That means, say for example, this is a neutral expression. Okay, so the same person, two faces of the same person. One is of neutral expression and the other is representing the happiness expression. Okay, so now naturally, what we have to let us try to appreciate this, that the person is same, the face is of that person only, but there are different expressions of the same person, and through this expression we are getting some emotional, clue of some emotional background that the person is in. So when I am talking about happiness expression, in terms of expression, it's basically an image, but mental state wise, that person is in happy state, so emotionally happy. So only then there is a correspondence between the emotional expression of the person under consideration vis-a-vis what is reflected in his or her face image accordingly. So now this particular association, or the correspondence, so to say, excuse me, they are not mathematically formalized. The biggest problem is this. If we ask that if the mental state is happy and its reflection or uh, its outcome is in the form of happiness as an expression, so the transition or the association between the emotion or emotional state vis-a-vis the expression, what mathematical transformation or what mathematical function is operative there? If the question is that, it's very difficult. In fact, it's not known. So naturally, this is the region where we are trying to make our study on and try to carry out our analysis and subsequently make some inference, meaningful inference out of it. So that is what the objective is all about. I hope our motivation is clear by now. So let us proceed accordingly. And as has already been mentioned at the beginning, that there are different approaches. For the present, there are 4 distinct approaches to achieve this goal. Now, this is the static image based, static image oriented, geometry based approach I am talking about. However, our objective is something more than that. Instead of static image, what happens is that we are considering dynamic images, where rather than a specific emotion of a human being that is available from a specific or individual image, facial expression image, that is not exactly our goal. Our goal is somewhat more next level or subsequent level, where instead of a single image, we are having a sequence of images of the same person, which indicates a transition or change in emotion. So suppose I am neutral now, but for some phenomenon or observing something around, I get irritated. So I become extremely angry. So naturally, there is a state transition of my emotion, from neutral to the state of, emotional state of anger. Now, intermediate, there will be image sequence accordingly generated, which the order of those images are very important. So, starting from neutral state to expression wise, from neutral expression to anger expression, that will be available. Now, this is basically dynamic scenario or video based scenario. So here it is. So there are different frames indicating that of the same person. So the leftmost is the neutral image, and the rightmost is the happiness, extreme happiness. So these are the intermediate states through which there will be different intermediate expressions reflecting different levels of intermediate emotional backgrounds. So the leftmost frame is representing the perfect neutral. The rightmost one is reflecting the perfect anger, complete anger, perfect happiness or complete happiness, and anything in between is a gradual transition from neutrality to happiness. So this is reflected in terms of or represented in terms of a video or sequence of images. Okay. So our goal is to identify the transition from one emotional state to another emotional state that is reflected in terms of a sequence of images or video images. Right? So that is what the challenge is for the present. So distortion of facial aspects is found when emotion evolves with several intervals of time. So naturally, if we look at the sequence of images represented here, we definitely appreciate that I mean, there is a gradual distortion of facial aspects or facial geometry, better to say, if I am permitted to say the term, because eventually we try to exploit the essence of geometry, mathematical associated with geometry to overcome this challenge. Okay, so temporal changes mean over time changes in motion can be recognized through frame by frame facial pattern analysis, or each and every individual image provides some pattern clue. So when they are put in an ordered sequence, meaningfully ordered sequence, they make some meaningful transition characteristics which we want to classify. So that is the task. I hope the problem is understood. Is it so? May I assume that what exactly we are trying to do is clear to the audience?
Yes, sir.
Okay. Let us proceed then. Now, this is just to formally identify that the foundation is efficient ways for tracking record regarding the deformation of face geometry over time interval, impact of various geometric representations on the transitional emotion recognition, okay, which is identifying in terms of accuracy or what is known as recognition rate in terms of percentage. So, excuse me. Okay, so now we are coming to the first out of the four methods, the first method which we are going to discuss or make our discussion on, which is triangulation induced various center pairs distance signatures for. I shall explain. First, let me allow me to read out, then I shall explain things gradually. The distance signatures for change detection of human emotions. So there are so many, technical terms involved here. So let me let us try to appreciate. First of all, triangulation induced. First of all, there is a question of triangulation. Triangulation means we shall see very soon that since we are to deal with geometry-based approach, so essentially there are certain salient points, what are known as salient points in a typical phase. So in fact, those are the coming as a salient points or contributing points in this particular type of analysis, where those points from the face or in a face image is very sensitive to any type of emotional change. Okay, so accordingly, a set of such salient points will be identified. Naturally, now what is there given a face image? There are certain set of salient points, and accordingly there may be different geometric figures that can be considered. So now essentially now it is coordinate geometry. It's a two-dimensional or planar coordinate geometry which starts making its presence felt from now onwards. What is that? Because given any three non-collinear points, it's possible to construct a triangle. Now what happens is that, so if there are say n many such salient points identified in a face image, we shall see by means of certain examples and figures very soon. Now, if there are n many points, so how many ways 3 points can be chosen to form a triangle? NC3 many points. So there are possible NC3 many triangles, and out of these NC3 many triangles, some may be very useful, very susceptible, some are not. And in fact, if these triangles and their properties or some triangle related information, they are numerical information or quantitative information, they are collected together, they form what is known as a signature. Here the order in which the triangles are considered is very important. Okay, we cannot distort that. So given a specific sequence of triangles considered, obtained from salient points in a face image, they play a very crucial geometric role uh, for classification and subsequent study analysis. Okay, so that is why it is triangulation we understood. So triangulation induced various center pairs, distance signatures. So there are signatures. Now the signatures are primarily signatures we have explained just now. Distance signature means basically if we consider a triangle, so we know that now it is geometry or coordinate geometry, as I have already mentioned. So there are different type of points associated with a triangle that we all know, say centroid, incenter, circumcenter, etc. So if two such points are considered, so accordingly these are center pairs. So these center pairs have got their distance in between. So now this distance in a sequence they are considered to form a signature. Now interestingly, this particular methodology is exploiting or trying to exploit that distance signature, center pair distance signature in different triangles formed out of these salient points on the face images of a facial expression, indicating the background, mental state or psychological state or emotional state of a person. And this is being used for change detection of human emotion. Now, if there is a change in the emotion, there will be a reflection in the change in the signature, characteristic, which is exploited, and accordingly, this is being classified. So, analysis of discriminating merit of each distance signature independently. I'm going to explain it with figures and further details very soon. Offer a significant platform for finding robust facial feature representations. Okay, so let us see how it works. So that is the flow diagram or course of action which are being followed one after another. So basically, there is a sequence database which is made available to us. Then the next point is, or next objective is, feature point localization. Then comes so-called triangle formation, or what is known as triangulation. And then there are in-center, circumcenter, distance signature, pairwise distance signature. So there may be in-center, circumcenter, it may be the distance between in-center, very center, in-center, off the center, so on and so forth. So there are 6 possible, types of distance signature we may consider. Accordingly, these signatures, they are used as features. They are used for MLP or multi-layer perceptron classification. Here, basically, multi-layer perceptron is used as the classifier. We may use other classifiers also, support vector machine or k nearest number. In fact, we have mentioned that earlier. So for the present, we have used multi-layer perceptron classifier only because of its popularity. It's otherwise it may be otherwise a primitive one, but very much effective even today. So accordingly, the MLP is able to classify different type of situations. So different type of mental states out of the face images. Okay, so that is what the flow diagram looks like. Now, these salient points is also known as landmark points. So landmark generation using active appearance model or AAM. So active appearance model is considered as a sort of a Bible for this particular community, research community on affective computing. So active appearance model is that type of a model which is essentially a particular journal reporting, which takes the responsibility, or which is being used for the purpose of identification of landmark points on a face image. So let's be focused. Let's focus on this. So this particular expression or this particular facial expression indicating an expression of this lady being genital lady. Now the question is, this is a face image, no doubt. Now see, there are identification of certain points. If the question is asked, what are the points or which are the points who are most sensitive on these face images and who are most susceptible to any change in facial expression? Now the question is very the answer is very difficult. Question is very simple, but the answer is very difficult. Now, active appearance model is that particular work or that particular reporting which is identifying, given a face image, which is identifying the landmark points, 68 many landmark points. This is particularly the reporting. That means given a human face image, the most salient or significant 68 landmark points which are most susceptible or sensitive to any expression, any change in facial expression, they are identified. So active appearance model is that reporting. So needless to mention, we must appreciate that is the reason why active appearance model as such is the first reporting in the literature which dealt with identification of those landmark points. In fact, what is even more interesting, that is face independent. These 68 many landmark points, they are independent of the subject. That means whether it is the face of mine or the face of X, face of Y or face of Z, or a lady or whosoever. So irrespective of whose facial expression is under consideration, what AAM, that means active appearance model, could establish is that the 68 landmark points are salient points which may be used for this purpose, and these 68 points are independent of the face of a specific person. Person is important, not important there. It's independent of the person whose face is being represented. Okay, so that is the essence of active appearance model. Now next comes is that 68 many landmark points admitted that they are the most sensitive points available on a face image or susceptible to any change whatsoever. Now out of the 68, we are identifying 23 landmark points. That means 23 many landmark points which are among these 68, which are the most contributed in terms of any change in facial expression. Now this is what is known as crucial landmark selection. This is yet another reporting which basically identifies, or what should I say, this is basically downsizing the feature space from 68 points to 23 many points, which otherwise is a very good contribution, because computationally dealing with 68 many points and making all analysis subsequently is extremely resource hungry. So getting hold of 23 out of the 68 with very little cost is definitely a good, something very, very welcome contribution, which is basically this particular reporting deals with. So now we are here. So what we are having here. So instead of 68 given a face, we have identified 23 many landmark points for our purpose, on which all the geometric considerations will take place. So essentially, given an image of a face right now, there are 23 many positions of 23 many landmark points which are being considered, and accordingly different geometries or geometrical considerations crop up. So look at it. This is the fourth one. So since 23 many landmark points are there, so 23 C3, that means so many different type of triangles can be considered. So how many distinct triangles are there? Given that 23 landmark points are identified, it is 23 C3, which is otherwise a very huge number. Okay, so basically our contribution or our basic task starts from here. So this 23C, let us appreciate now, this 23C3 many triangles, they have their respective shapes. Now we index these many triangles in a particular order. Okay, and any property of a triangle, that means it's a basically 23C3 long vector in a specific order. So any combination, any feature, quantitative feature coming out of it, 23C3 many, it gives a 23C3 dimensional vector, basically. It is a signature vector. If we deal with some sort of distance, then it is a distance signature. If we deal with something else, then it is a signature based on that, so on and so forth. Okay, so this 23C3 means 1771 triangles are formulated. Okay, so that is what our background is all about. So basically, now what? Given a face image, we have got 1771 dimensional vector, basically 1771 dimensional vector, which forms a signature of importance or significance. Now the question is, naturally, we may be able to specify different type of signatures for different purposes. Okay, so given a triangle, it has got so many properties. So any property may be considered or may be taken into account. Now some of the properties may be useful in our context, some of them may not be. In fact, that is what all the cultivation is about. So which are not very much influencing, or they're not very much significant, they are basically left behind, they are set aside, not considered for further investigation and study. Only those signatures which make some meaningful contribution, they are considered. Okay, is it all right? Am I audible?
Yes, sir. Yes, sir. All right, sir.
Okay. So now the stage is set for further, consideration. So look, so this is our face image. Okay. Now this is the original image. So there are different combinations. So think this particular, consider this is just an example. Consider this landmark point, and this landmark point. Okay. Now these three are going to form a triangle like this. So everything is geometry now. Okay. So given this triangle, this is the triangle here. Given this triangle, we are considering the circumcenter and incenter. Circumcenter and incenter. Okay. So circumcenter and incenter. So given a triangle, we may have a pair incenter and circumcenter defined. Given a triangle, once the incenter and circumcenter points are identified, we may calculate the distance in between them. So this is the distance between incenter and circumcenter. So given a face image, given a particular triangle, which is definitely one component of this 1771 many long vector, this is just a typical example. and we consider the distance. Okay, which distance? In center circumference distance of that particular triangle. So how many such distances will be there? 1771 many distances. So 1771 many distances between in-center circumcenter. In short, it is represented as IC. I stands for in-center, C stands for some circumcenter. That is why it's a pair, IC pair. Okay. Similarly, IB. So given the same triangle, there may be in-center, center. Accordingly, the distance may be there. Okay. Then IO, in-center, ortho-center. Accordingly, there will be another distance. So what is coming? Accordingly, there are 6 many. Okay. So given the same face image, a specific triangle drawn from by considering specific 3 landmark points, okay, we'll have 6 such distances, different distances. Okay. So how many such 6 set distances will be there? 1771. Right? So this is in relation to a specific face. Now, whenever there is a change, next comes the question. Whenever there is a change, let us try to appreciate this. Whenever there is a change, suppose I become a bit smiley from neutral position, these distances will undergo serious and severe changes. All the 6. Okay. So naturally, there will be, so far as that particular position of the vector is concerned, 1771 long vector is concerned. Okay. All these 6. So it is 1771 into 6 basically. 1771 into 6, so to say. So all these will undergo changes. So that position is going to face, feel some change. Right? That is what the clue is. So when we are talking about or thinking about a frame of, sequence of frames, we consider how these distance signatures are changing over one image to its next. So this transition is characterized. And what is important is that, let me make this point clear. What is so neutral to surprise? The change is something different from neutral to anger, which will be different from neutral to, say, happiness, so on and so forth. Okay. So now, given this distance signature, if they are trained properly, now the question is, from that we try to, our objective is to identify which type of emotion transition is taking place. That is what the way we try to deal with. Is it okay? Is it clear to all?
Yes, sir.
So that is. Now, when it comes to the question of, these are basically features. So this 1771, such, so given an image, this is a neutral image, okay, and this is a surprise image of the same person. So for each and every image, you have got a vector like this. With each and every vector may have 6. Each and every position may have 6 such, center pair type of information associated. So each and every such, if there is a sequence of 10 images representing the transition from one emotional state to another, so for each and every one you will be having this type of a scenario. Now this is 1771 into 10, considering a particular pair. Okay, so given a particular pair, it will be 1771 into 10. So this many vector. Okay, so that is that is fed in this classifier, which is multi-layer perceptron. I presume that multi-layer perceptron is somewhat clear to the audience or people around, people in the audience. At least they have got the basic idea about how a perceptron works, or what exactly is the way a multi-layer perceptron, or for that matter a single-layer perceptron works. So it basically plays the role of a classifier. So accordingly, with these informations, this classifier is trained. Okay. Now, once the training is complete, then this classifier becomes an intelligent classifier. Intelligent in the sense that once they are trained, once it is trained, if at a subsequent point of time a new unknown input comes, then it is through this past experience, that is why it has become intelligent, because of its training. It is capable of identifying which type of class this particular input belongs to. Okay. So now this particular approach has been considered, or better to say, applied on different so-called benchmark data sets. So these are 3 benchmark data sets available in public domain. One is extended Concanade, I mean CK plus data set. Then there is MMI data set. Then there is MUG data set. Okay, so so these particular experimentations have been taken or have been considered on these benchmark data sets, because benchmark data sets are those data sets which are which people accept, and this is not otherwise challenged technically. So these are the results that we obtain by applying our method, this distance signature based method, on different data sets. Now, performance metric is considered in respect of this type of metrics, which is one is FAR, FRR, ERR. So these are, FP stands for false positive, TN stands for just a moment. TN stands for true negative, true positive. TP stands for true positive. False positive is false FP, and false negative is FN. So accordingly, these 4, FP, FN, TN, and TP, on the basis of them, different type of performance metrics are considered: FAR, FRR, ERR, etc., so on and so forth. So that way, just a moment. Okay, so these are the 6 type of situations. One is in center, circumcenter, if we consider. So this is the performance that we obtained. Very interestingly, let me explain. So A, C, D, F, H, S, C. So these are basically different type of expressions. So a particular one represents that if the actual identification is, say, for D, if the actual expression is D, but it is classified as A, that is reflected here. If the actual expression is, say, fear, and it is classified as disgust, D, then it is represented here. So different cells in this particular matrix represent different appropriate one, or observed one, and actual one. So how these are represented, this is called confusion matrix. So this is a typical CK plus confusion matrix with respect to different type of 6 possibilities. in-center, circumcenter, that's IC, IB, IO, etc. So these 6 type of different distance signatures are considered, and accordingly this is what our method has reported in terms of performance. Coming presenting in terms of FAR, FRR, or ERR on CK plus, these are the expressions, or I mean these are the different possibilities we have obtained, where all the 6 distance pairs have been considered and represented in different with different colors. So this is graphical representation. Now these are certain these are the reportings of this. Top portion is the reporting of, that is how our classifier worked, or how they have reported. Vis-a-vis, these are existing contemporary methods, which are basically states of art, other works of other people or other researchers. So accordingly, this is a snapshot or synoptic view of possible comparative performance comparison. So to put it linguistically, the observations indicate that fear is the most difficult emotion to be recognized. Very interesting. I am not very convinced, or I am not very confident to justify why fear is the most difficult emotion. If there is any medical interpretation of that, I am not aware of. But computational point of view, it's very queer an observation, but it is revealing so. So fear is the most difficult emotion to be recognized, as only in-center, circumcenter, distance signature reports a 100% recognition rate for fear emotion. Otherwise, performance is not that encouraging. All 6 distance signatures provide the most promising recognition results for happiness emotion. When it comes to the question of happiness, it is a different story altogether. Okay, more unique triangles in happiness emotion than others. So happiness, or picture of happiness, is something we should be happy about, I should say. Okay, so when it comes to the question of in-center, circumcenter, distance signature, when that type of signature is considered, the overall accuracy, highest overall accuracy is being reported. Okay, so this is what is the empirical finding that is obtained out of it. Coming to so whatever we have discussed, or whatever we have presented earlier, it pertains to CK plus. There is another data set, another benchmark data set on which we have carried out our method and classifier, and this is the performance. Okay? This is MMI data set, yet another benchmark data set. Okay. So this is the performance metric, FAR, FRR, ERR. This is on MMI. Right. And this is the result comparison on MMI. Now, fear and sadness are not properly identified. Overall observation is there. Once again, here also these are our contribution part, and these are the other reportings. So fear and sadness are not properly identified. It implies that they share common triangles with other emotions and becomes confused to distinguish them from others. So possible overlap may be one of the reasons, because one triangle has got overlap with another triangle. So because of that, this type of syndrome is appearing. It may be so, but it is very difficult to interpret otherwise. Maximum overall recognition rate 92.57% is found by in-center, circumcenter, or IC distance signature, so far as MMI dataset is concerned. Coming to MUG, the third and the other dataset, benchmark dataset. So this is the confusion matrix reporting. Okay. Well, PAR, FRR, and ERR reporting in MUG, they look like this comparatively. I mean, their comparative representations look like this. And coming to results, now when it is the question of MUG dataset, the fluid emotion of the MUG dataset contains a higher amount of unique triangles in terms of unique features compared to other emotions, as it is strongly recognized by all 6 distance signatures. Very interesting. Very interesting. The same classifier, please recall, the same classifier when it is being applied on CK plus, fear is the, I mean, the performance of fear was very much, very much awkward. But the same fear emotion in MUG dataset, our classifier is performing nice. It's very interesting. Okay, so what does it mean? It means that one classifier may be encouraging on one dataset, but may not be on others. So it is the data on which the particular classifier is being applied. It also is very important. Is also very significant. Okay, then comes very center, orthocenter distance signature ensures the highest overall recognition result. So far as this classifier, MLP classifier, our MLP classifier is concerned. Okay. Now, there was a question. What is the result of tenfold cross validation? So that is also reported here in terms of CK plus, MMI, and MUG. So 6 different distance pairs. So accordingly, 6 different tenfold cross validation performances have been reported. Okay. So this is the complete reporting, empirical as per the empirical findings of application of this particular classifier, MLP based classifier on this type of a problem. Okay. I am not going to discuss it, just to state you, this is there was a question that came up, since it is a reporting on a thesis. One of the examiners, learned examiners, he pointed out that what if different combinations are done, rather than considering, say, individually S1, S2, S6, why not all possible combinations? So it's basically sort of power set of the different combinations. So since there are 6 many, okay, so 2 to the power 6 many possibilities are there. So consider all of them exhaustively, okay, and report whatever findings are coming out. And then the 2 to the power, out of this 2 to the power 6, when that means 64, one is definitely the trivial one where all are excluded, so that is discounted. So 64 minus 1, this means 63 many possible combinations, all possible combinations may be considered. Accordingly, out of these 6 sets, so these are the entire reporting. So it was just one of his observations, so that is complied there. It's not otherwise not a very important issue. So to sum up, these are we have already summed them up. These are all the finding of this particular methodology. Okay, so I am not going to discuss it further because this is what we have already discussed. Coming to the publications, this is the publication that could be achieved out of this particular reporting. Okay, so this is one method that we have uh, completed, right? Uh, there are other methods. This is the second one. Um, I think before the second one is explored, may we have a break for say, some few moments, maybe for 5 to 10 minutes? Is it possible?
Yes, sir. No problem.
Okay, so let us assemble after 10 minutes. Okay, that will be nice. So we
Okay,
are
sir.
reassembling after 10 minutes time. So then we shall go for the next one. Okay, thank you very much.
Okay, sir.
Participants, there is a 10 minutes break. After that, sir will again continue. So you may join at that time.
May I start? Good afternoon.
Yes, sir. You may start the session.
Thank you. So let me share. So is it visible?
Yes, sir. It's visible.
And hopefully I am audible also.
Yes, sir. You are audible.
So let me start. Okay. So this is yet another technique. So after the basic background is clear and the objective of the present task is clarified, and one of the methods we have already explored, which is distance signature, pair-centered distance signature based geometric technique. So the next or another method is where altitude, that means a separate or different signature is considered, which is altitude signatures, which we are going to explore now. Okay, so it's basically we are considering different forms of geometric features or geometric uh, information characteristics for our purpose, and they are being tried to exploited for the purpose of appropriate or good classification. So that is what it is. So let me explain. I think so. Consider this is our face, for example. Now let us introduce the concept of altitude for the present context. So uh, so these are basically if this is a triangle, say ABC. So there are three altitudes. Say H1. That means the figures may not be that much nice, but it's understood. That means we drop the perpendicular, and accordingly the altitudes are considered. So these are the, I mean, mathematical relations, different altitudes, so that we know there is nothing new in it. Just these things are used for the computation. So the way the encoding is done, I am not going into the details of this. In fact, I specified or mentioned that I am not going into the details of mathematics because otherwise the concentration may be lost. But just only one thing to say is that this, so far as constructing this present altitude signature is concerned, uh, these are different ingredients that are considered for our purpose. So different, mathematical, what should I say, mathematical expressions are considered, and eventually what we get, we get so there are different frames, there are different sequence index. Um, then there are, for each and every triangle, there are three possible heights. So H1, H2, H3, and these are the angles, these are the sides. So accordingly, 3 plus 3 plus 3. So nine many informations are basically maintained for, I mean, specific sequence, image sequence, and ijk being the vertices of the triangle. They are indexed like that. So three sides, three angles, and three altitudes of triangle respectively, they are taken into account. And in order to have this, these are the formula that we use. So essentially, this is our feature. That is what you use. And by using that, it's a different feature. So by using that, what we get? So As before, we have applied this altitude signature on CK plus MMI and mark data sets with MLP classification classification technique being applied or adapted. And when it is the question of training, validation, testing, earlier also it was possibly not mentioned, but earlier also this is the convention we have followed. So it's a 70%, 50%, 15%, 15% distribution among training phase, validation phase, testing phase. So here there are other performance parameters used. So recall, precision, and then F score. So these are the respective formulae. Okay. So for CK plus, corresponding to three altitudes, these are the classifications or accuracies reported. For MMI, these three. For MUG, these three. Sorry. So for each and every data set being considered, there are three altitudes, and corresponding to each and every type of altitude, there may be three accuracies reported, or better to say uh, three ah, so they reflecting the performance in terms of these confusion metrics. So each and every corresponding to each and every altitude signature, this is reported. So coming to recall, precision, and F score, the metrics, performance metrics used. So these are the reporting. AN stands for anger, um, disgust, fear, happiness, so on and so forth. So these are the six. Surprise. This is neutral basically. So accordingly, these are the different situations or different reportings. Incidentally, this is not always very promising. Particularly for fear, there are low accuracies reported or low values of say recall is not that much impressive. So it's a sort of a mixed type of scenario that crops up. In fact, we have also earlier seen that fear in certain situations make your life a bit difficult. Okay, so that is also reflected here. So this is the performance comparison. This is basically comparison in terms of the test of overall accuracy, and this is what is reported in respect of tenfold cross validation. Okay, so that is the overall reporting of this particular technique. Compared to other techniques. I'm sorry, just a moment. So these are different methods. 13, 14, 15, they indicate different methods, different states of art with which we have our comparison or comparative performance. So this is what exactly it reveals how our performance, our method of altitude signature performs compared to others. So here also these different type of sets, sort of power set elements are considered like before. So this is the finding. Fortunately, Here there are not that many options. So this is the sum of discussion which is available from the discussion on this particular type of method or technique. So in certain situations, apart from certain specific sporadic situations, overall impression is quite impressive, and this is as per the empirical findings suggest. So this is the publication coming out. Right. Okay, so this is second method. Coming to the third method, um, which is which we are going to take up now. And in my opinion, this is the most interesting one. And let me introduce it. I mean, the interesting part of the whole thing is fuzzy triangulation. So the question of triangulation, earlier triangulation, whatever we have considered, there was nothing fuzzy about it. Everything was very much, very much classical or crisp in that sense. Now the question of flexibility in terms of triangulation characteristic is taken into account. And because of this flexibility induced, we enjoy other, interesting or important advantages we derive. Okay, so, but before we go into that, let me give you some basic idea. Let us share. See, we know, for example, what is a right angle triangle? A triangle where one of the angles must be of 90 degree angle. Okay, so this is right angle triangle. There is no dispute, no doubt. Everybody around in the world is going to accept it. But this formulation or this definition is in the sense of classical definition of right angle triangle. Now suppose instead of 90 degree, if it is 89 degree, then say 12 degree or say 11 degree, 49 degree, 89 degree, 11 degree and 80 degree. Question, if the angles of a triangle are like this, 89 degree, 11 degree and 80 degree, is the triangle a right angle triangle? In classical sense, no, definitely, because none of the angles is 90 degree in terms of measurement. But in fuzzy sense, it's very close to, because by virtue of one of the angles being 89 degree, which is quite close to 90 degree, it may be considered as the right triangle, but in fuzzy sense. So it is a fuzzy right angle triangle. So what you do, instead of being very much specific and focused, we make a flexibility to some extent, some meaningful extent. And the moment we accept it or inject it, it is going to provide you interesting, flexibilities that you may enjoy for your computational purpose. Now, the question is why we are adapting fuzzy triangulation in that sense. The reason is that this type of application where triangles are being considered on face, on landmark points on a face image, because of the different type of shapes of different persons or faces of different persons, this type of flexibilities may be extremely useful, if not needed, because shapes of face of different persons vary from one person to another. So because of this flexibility, you cannot expect uh, justice being rendered if you stick to specific type of triangle characteristics, geometrically speaking. So you need to have, need to arrange some sort of flexibility in the definition itself of different types of triangles. So triangles in classical sense, in terms of classical definition, may fall short of rendering justice to situations arising out of different type of flexible situations, or approximate type, several types of approximations, uh, because of the inherent impreciseness of this type of application. So that is the reason why it caught our imagination, and we thought, why not explore, or channelize our exploration, or why shouldn't we cultivate that? So this is the background. Now, in fuzzy triangulation signature, uh, for change detection of human emotion, which is being considered now, so the frame-based facial expression analysis to estimate flow control of behavioral changes in the transition of human emotion, available in terms of video clips. Okay, then the question of introduction of fuzzy triangulation, which we shall be trying to discuss, may not be to a very deep level, but to a meaningful uh, detail as may be required for the present purpose or present scope. Discussing the separately significant influence of 5 different fuzzy triangle membership signatures. In fact, this we shall see that different type of, because of fuzzy triangulation, different type of possibilities would crop up, which would be clear once they are introduced. So here is the roadmap of this particular study. So you have got your image sequence. Similarly, here the landmark points are detected using AAM. Okay, then instead of this block gets changed or altered. Instead of specific type of triangles, or classical triangles in classical sense, and their distance calculated accordingly, applying them as we did earlier, we are considering now fuzzy triangles, or explore fuzzy triangles instead. And on the basis of those fuzzy triangles, some of the features are coming out. We shall identify those, or get hold of those features, and those features are being fed in our classifier, which is once again a multi-layer perceptron based classifier, and we get the result whatever that comes out. So that is what the roadmap is. Here the basic idea is, so this is your face image. So accordingly, a triangle is classified maybe in 5 different ways. One is fuzzy isosceles triangle. We know isosceles triangle, right? Now, fuzzy isosceles triangle means it's isosceles with having some, or enjoying some flexibility in terms of angle value. May not be very major, but minor. Minor deflections are allowed in terms of the value of that angles. So accordingly, you corresponding to isosceles triangle, we will be having fuzzy isosceles counterpart. Corresponding to right triangle, you have corresponding fuzzy right triangle counterpart. Isosceles right angle, corresponding to that, you have fuzzy isosceles right triangle. Corresponding to equilateral, there is fuzzy equilateral. Apart from, or other than these, there is the other category, which is none of these sort of category, which is other fuzzy triangle membership, or other fuzzy triangle. So particularly dealing with a triangle which essentially which is not going to get close to any one of these earlier four. Uh, uh, I am not going to deep into the mathematical derivations. Just one example will be better for your understanding. Let me provide it, which says that, for example, uh, if we consider an equilateral triangle, ideally a classical equilateral triangle should have angle distribution 60 degree, 60 degree, 60 degree. Now, if the triangle distribution is say 59 degree, 60 degree, and 61 degree, is it an equilateral triangle? Answer is no in classical sense, but answer is yes in fuzzy sense. So we allow 1 degree of deflection from 60 degree, and since we are allowing this flexibility to be injected, as against we get, more flexibility in terms of the results that we obtain. Interestingly, if we consider CK plus theta base, so we get this type of, using this fuzzy isosceles triangle signature. This concept of signature is very much there. Only thing, this particular feature gets altered. Okay, so now by using fuzzy isosceles triangle feature, and the signature obtained out of that, so this becomes your confusion matrix. Okay, with fuzzy right triangle, this is your confusion matrix, so on and so forth. So corresponding to 5 type of fuzzy triangles or fuzzy triangulation, there are 5 independent, or I find 5 separate confusion matrices corresponding to CK plus. Clear? Okay. Now, if it is asked, what is the performance? So this is the performance corresponding to 5 different type of signatures. Okay. So this is the comparative. This is the FAR reporting. This is FRR reporting. This is ERR reporting. Okay. So put the comparative, the analysis in text. What we get, all signatures are able to find out the common pattern of changing behavior over the transitions of happiness and surprise emotions. So this is what is revealed in this particular table that will be presented here. The fear transition is found more difficult to detect perfectly. Once again, fear is your source of fear, right? So fear is creating all your problem, all your trouble. Fuzzy right triangle signature and fuzzy isosceles and right triangle signatures are showing higher performance than the other signatures by achieving more than 98% overall accuracy. So if you recall, the earlier overall accuracy reported with other methods, vis-a-vis here using fuzzy triangulation is providing you higher accuracy, higher overall accuracy. This is because of this flexibility that you enjoy by injecting this sort of deflection, which was not possible earlier. So philosophically speaking, I am dealing with a scenario where there is every scope of imprecision, and imprecision cannot be tackled by precise mathematical framework, precise geometry to the fullest extent. This is not to say that, first of all, here fuzzy being capable of dealing with certain uncertainty or certain imprecision uh, is expectedly performing better. Number one. This is not to say that the fuzzy is the only option to overcome this. There may be other options, maybe hybridization. So fuzzy maybe coupled with rough. Then there may be the concept of vague set or other type of imprecise mathematical frameworks may be useful to consider or to construct your appropriate signatures for this purpose. So these are endless. For our purpose, we have confined our discussion with this to this only. So apparently, this is the reason by introducing or allowing or permitting this flexibility to some extent, we are arguably getting the better overall accuracy performance. Coming to MMI dataset, so these are the 5 confusion matrices, different performance parameters comparatively shown here. As far as MMI dataset is concerned, these are the findings. MMI dataset is found pretty challenging to recognize all basic emotions. FIS and FES showing impressive performance, but impressive with respect to his other counterparts, but please look, this is 93.56%. So the best one is to the tune of 93.56%. So that is why it's called that MMI dataset is pretty challenging in terms of the way different benchmark data are made available. So coming to mark data set, these are the five confusion matrices corresponding to 5 type of fuzzy triangulations. These are the 5 these are the performance measures, FAR, FRR, ERR for all these 5 triangulations, for 5 triangulation techniques or 5 different signatures. Coming to this particular results analysis corresponding to MAG, what our finding is maximum shape variation information is collected from the transition of fear emotion. Once again, fear. Transition of happiness is found more difficult compared to other emotions. Here, interestingly, so far as MAG is concerned, happiness is also making your life a bit more tricky. FRS and FIRS ensure more impressive performance, overall accuracy above 99%. So this is the story with MAG dataset. Coming to comparison, overall performance comparison. So above, this is 10-fold cross validation. This is the comparative scenario of overall accuracy at the bottom. Comparing with other states of the art, our technique vis-a-vis other existing techniques. If we consider the combinations, so different combinations are considered. So these are the findings here, because this is going to take much time. Okay, so we have covered 3 different techniques. With each and every technique is having their respective pros and cons. We could not, because of paucity of time, we could not complete the 4th one. So let us stop it and call it a day. So thank you for all your patience and all your endurance, patient hearing, and all your cooperation. So that is something which I tried to share with you. make
Thank
some,
you so much, sir.
yeah.
Thank you so much, sir, for your sharing your knowledge with us. I think a lot of participants will be benefited from this session. It was indeed a great pleasure to have you with us today. So we conclude here the first morning session of the FDB, and let us just take a lunch break. And after that, we will be returning back by 3 p.m. for our second session.
Thank you for
Thank you
your
so much.
opportunity. Thank you.
Thank you, sir.
May I leave, please? Your
Yeah,
kind
sure,
permission.
sure. Sir.
Thank you.
The attendance link has been shared, so kindly give your attendance in that link.